So one of the environmental benefits of mass timber is that the manufacturing emissions are much less carbon intensive than traditional structural materials like concrete and steel. To get a CLT panel from the forest is much less carbon intensive than extracting the ore, extracting the iron ore and manufacturing a steel member, for example. So the other piece around mass timber that makes it potentially very sustainable is the concept of biogenic carbon. So when the forest stand grows, and photosynthesis occurs, the wood itself captures CO2 that's in the atmosphere and uptakes it as part of the wooden structure. And so wood is typically around 50% by weight CO2. And 1 metric ton of CO2 is stored per cubic meter of wood. And so, looking at biogenic carbon, with wood products and then other biomass products, that's replenished on a cycle of around, less than 40 years. Whereas our traditional means of obtaining structural materials, fossil fuels, also known as geologic carbon, replenish on a time scale of over 60 million years. So when looking at structural materials, mass timber that can sequester biogenic carbon within the structure, you're looking at something that can potentially store that carbon and be a climate change solution. One caveat to that is to ensure this cycle, products should be selected from sustainable forests, and that's certified through certifications like FSC. So to illustrate, what that could really mean, I have a example project here that was considering a traditional approach to structure versus mass timber. So on the first column here, we have the baseline total embodied carbon of just the standard baseline steel and concrete approach. This second column shows that if you optimize the steel and concrete for reduced embodied carbon, you can achieve, in this case, around a 35% reduction, so significant. This third column showed if you used mass timber instead of most of the concrete and steel, you would achieve a 47% reduction from that baseline. However, the big savings come when you're using a certified wood for a mass timber project here, because you're actually able to account for the biogenic carbon, so the carbon sequestered within the wood structure itself. You're able to account for that as a negative. And so that results in an 82% reduction from the baseline. So there's a huge amount of potential in terms of carbon reduction here. So, despite the significant environmental benefits, uptake in mass timber projects in the Bay Area hasn't been that rapid. So in the US, we're seeing a lot of uptake in the Pacific Northwest, and globally, it looks like it's centered around Europe as well, where this has been practiced for a few decades. But there are a few projects, and I'll be talking today about 3 of them. So the first project I'll be talking about is the One Dejaro project. It's located in San Francisco. It's a 132,000 square foot, 4-story office and kind of light industrial building developed by SKS. And see the team here, Fowlong, Perkins, and Wells are the architects, DCI, the structural engineers, Hathaway, Dinwiddie, the GCs, and Nordic Structures are the mass timber suppliers. So as you can see in this photo, it's a 1-story concrete podium with 3 stories of mass timber built on top of that. You can see the glulam columns and beams, and then the CLT decking that's installed right over that. And take note of what you're seeing here with the construction methods, and I'll give you some details in a few slides on how fast they were able to do this, which is pretty stunning. So you can see here, and really what's interesting, you know, mass timber was pursued in this case as a, you know, as a differentiator. And you could really see, you know, just driving down the street, this just looks like a totally different type of a construction site. So here is the full full structure assembled, and this project will be complete later this year. So some key lessons learned around this project, thanks to DCI and Hathaway for these. So it's critical for mass timber projects to define the wood species early in the project when you're still doing the structural design, because different types of wood species actually impact structural calculations differently. So in this case, black spruce was used. Another lesson learned was were the significant weight savings that were achieved. So mass timber, you know, weighs less, you know, per structural efficiency than concrete and steel. So the remaining concrete and steel that was used on the project could be undersized compared to a traditional approach. You know, and this resulted in material savings and cost savings to the client. I mentioned schedule earlier, and you know, what they found was one trade consisting of 6 people could put together an entire CLT deck in 2 weeks. And so that's, you know, it was significant savings in schedule just on kind of the deck by deck basis, which is great. We're also able to find some, you know, best practices around working with the mass timber supplier in particular. So it was super important for early involvement with the mass timber supplier. So coordinating on things like mechanical penetrations was really important, and getting the BIM, getting the models aligned was super important earlier than, because these large panels come shipped together and they're basically assembled on site. Additionally, it was super beneficial to this project that Nordic Structures controlled their entire supply chain. So Nordic owns millions of acres of forest in Quebec. They manufacture these products themselves, and they ship it all to the site, and they also manage all the installation. So kind of having that turnkey approach was really helpful for this project. Great. So shifting gears to another project. So this is a tech campus located in Mountain View, California. It's 644,000 square feet, and it's 2 stories, and aimed to be completed also later this year. The architect is WRNS Studio. Holmes is a structural engineer. Rudolph and Sletton is the GC, and Structurlam supplied the mass timber. So unlike the last project, there's no concrete podium on this one, but it does employ a bit more steel than the last project. So it's a 2-story kind of hybrid structure where there's the CLT decks with a concrete topping slab that you can see in this photo. With the glulam columns, they're actually wrapped in this photo, but you can see them here. And then these steel support beams, which are kind of across here. And you know, in this photo, you can really see how, you know, you can see the full cross section here as they're hanging the curtain wall. An interesting side note on the wood for this project. So lodgepole pine was used for about half of the wood. And some of this wood has been damaged by the mountain pine beetle, which is a big issue in some forests. And on its own, the wood couldn't have been necessarily used in the form of, you know, 2x4s. But due to the engineering process and putting it together with a lot of other wooden components, they were able to salvage that wood and use it in a structurally sound way. And you could actually see, I don't have a good photo, but you can actually see in certain parts of the building, there's kind of a blue stain on the wood. You know, that tells a story of this kind of pine beetle. Just kind of a really interesting, interesting story to tell. So some lessons learned around this project. It was really important to select the right contractor. So selecting a contractor that had experience with mass timber, so there wouldn't be any kind of crazy markup. And Rudolph and Sledden in this case, had that experience and were able to perform. Also, there's additional winter construction considerations here. With the wet weather and having a wood product, there's certain water staining material protection considerations you have to take into account here that you wouldn't on a conventional project. Defining dimensions of the products early is really important. So different suppliers have different press capabilities and panel dimensions they want to work to. And so defining that to really aid in the design early is important. And in this case, the CLT panels were 10 by 22 feet. I kind of mentioned the importance of BIM model coordination, MEP coordination really early. It was the same case on this project. The penetrations were CNC routed, and you could see an example here, kind of on site with at the manufacturing facility. And so that was kind of critical in this case. Final lesson learned is the importance of detailing the connections between the different materials in the building. So it's important to consider fabrication limits, how the contractor is actually going to put the building together, what different trades need to be coordinated on different segments, and then the tolerance of different materials. Great. So finally, I'll touch on a bit of a different one. And you may be familiar with this project if you've ever been to Lake Merritt in Oakland. So this is the Cathedral of Christ the Light. It's kind of at the northwest point of Lake Merritt. And so this was actually completed back in 2008. So it really predates the recent push that we've seen around mass timber. It's 322,000 square feet and kind of 5 stories, and it's really interesting shape. The architect and structural engineer were SOM. The Webcor was a GC, and Western Wood Structures was the mass timber supplier. You could really see in this photo. So basically, it was an 18-foot reinforced concrete substructure with glulam members that are tension supported with structural steel rods. And the inspiration for this was kind of the form of a vessel or a ship. And this was actually designed to withstand a 1,000-year earthquake, which is pretty cool. Some interesting photos from within. You can really see the connections here between the glulam and the concrete base. Couple projects on the horizon. Both are in San Francisco. Mass timber projects in San Francisco. We have Pier 70. It's going to be 310,000 square feet, 6 stories. So higher than most of the projects I covered. And then we also have the California College of the Arts, which is also going to be a beautiful building. And that's it for me.
All right. Thank you, Boris.